Okay, this time I guess I have the answer choice circled because the other sheet, the printing was weird, or didn't show up. So anyway, we know the answer ahead of time, but let's see if we can make sense of it. A 20-meter ladder is sliding down a vertical wall, so the distance between the top of the ladder and the ground is decreasing at 8 meters per minute. At a certain instant, the top of the ladder is 12 meters from the ground. What is the rate of change of the distance between the bottom of the ladder and the wall at that instant? So let's get a picture. Okay, so a 20-meter ladder sliding down a vertical wall. So here's my wall. And that ladder, it's a constant 20 meters. So I like to label all my constants in my diagram. If it's not varying, I don't think it needs a variable. So so that's the case. The top of the ladder and the ground, it's decreasing. So it says the distance between the top of the ladder and the ground is decreasing at 8 meters per minute. So let's call this, right, this distance here is what they're referring to. Okay, so if that distance is decreasing at 8 meters per minute. So we know now that rate, dy dt, is decreasing, so negative 8 meters per minute. And it says at a certain instant, the top of the ladder is 12 meters from the ground. Okay, what is the rate of change of the distance between the bottom of the ladder and the wall at that instant? So they're referring to this length, which we need to give a variable. Okay, so we want dx dt at the instant. So what is this instant? It's at the instant that the top of the ladder is 12 meters from the ground. So that's when in our diagram y is equal to 12. Okay, so let's relate these variables and then relate the rates. So what relates these variables in the diagram? Well, it's the Pythagorean theorem. We take the derivative of both sides with respect to time. Okay, notice this is 0. This becomes 2x times dx dt. This becomes 2y times dy dt. All right, and so then what do we know can substitute? Well, clearly, well, first of all, divide both sides of the equation by 2. No, those are gone. We know dy dt, so like that will fill in. This is at the moment y is 12, so that's going to get filled in. We don't expect to fill in dx dt because that's what we're looking for. But what about this x here? Well, I can get this x by understanding that at the moment in question, at this moment, the diagram looks like this. So this is 12, that's 20. And like we're trying to find what that is. So I think it's 16 because I think I see this as I'll let you do the Pythagorean theorem on that, but I see if you divide by 2, you get 10 and 6. So this is a scaled up 6, 8, 10. So 16, 12, 20 should be right. All right, so at this instant, x is 16. And so now I can write 16 times dx dt plus y is a 12. dy dt was negative 8 if you look above, and that equals 0. So now 16 dx dt plus, what is this, 89, negative 96 is equal to 0. So dx dt is equal to 96 divided by 16. Makes sense it's positive, right? Because if that's ladder sliding down, then the yellow distance is going to increase. So that makes sense, and that becomes 6, which we saw up here.